Thank you very much. Hello everyone, it's great to be here in your lovely city. I came today from Birmingham and I have been in your city a few times, and today was actually very interesting because I was able to meet my uncle who lived in the city. So it's such a lovely city you have, and it's an honor to be here tonight. Today I'm going to give you a very overview, like kind of a brief overview of AI landscape in Azure, and in particular I want to focus in one of our new technologies called AutoML, which I believe is the state of the art of machine learning. So I am an advanced analytics and AI specialist in Microsoft with a kind of an academic background in machine learning. So before I start my talk, I thought it would be a good way to celebrate this event, International Women's Day. And I want to start with a video. Hopefully you all can hear that. Well, I think you cannot hear it, so let me try it again.
One inventor is Benjamin Franklin. Leonardo da Vinci, Thomas Edison, Albert Einstein, Nikola Tesla, Alexander Bell Graham.
Oh, I'm sorry, I'm very sorry, I just accidentally stopped the video.
My favorite subject in school is science, because you can invent all different kinds of cool things, and there's like no limit what you can do. One inventor is Benjamin Franklin. Leonardo da Vinci, Thomas Edison, Albert Einstein, Nikola Tesla, Alexander Bell Graham. No. Not a tough one. In school, it was always a male inventor. I just realized. Oh my god, there's so much. I didn't even know that stuff. You're surprised because they only talk about Einstein and Benjamin, but you never hear a girl in conversation. To know that there were women before me, it gives me like motivation that I can invent something and make maybe like a change in the world, and that would be really cool.
Well, I hope the sound quality was good enough for you to hear the video, and I think actually it's quite shocking. It's the way this video has been made is very, as well as it's very interesting, is also very shocking that our children and the generation, they are not aware of female inventors. And it is because of our education system, our society, and this is our responsibility to make this change. And I am speaking here today as a female in take over 10 years. I studied at university, and I am originally from Iran, and I left my country in age 24. I went to Australia, did almost 10-year degree in master and PhD in computer science, and then once I become an Australian citizen, I decided to travel around and come to this lovely country of yours. And since then, I've been like in different industrial environment. and academic environment as well. And what I have noticed as a female in tech environment, as much as female are very bright and sharp in getting to the digital world and trying to prove themselves, it always required an amount of work for them to be recognized, to be acknowledged. And at the same time, there's a trend that trying to sometimes overrate what women do. And sometimes I hear from colleagues, male colleagues, oh, you are a woman, you're gonna get promoted, because they think sometimes they want to try the equality, so they wanna give you more chances to compare to male colleagues. And I think this might be the most insulting thing that you can tell a woman, when they are good for the things that they do, but people think, okay, you get a favor because you are a woman. So I think there is a lot of things to do in recognizing women, and one of them is celebrating this day. And not only in tech environment, we have very great leaders around the world in different domains and societies. So we must all accept the fact that women are as good as men, and it's not because of the gender, it's what you are good at it. And I want everyone in this room tonight, if you have a bias about the gender, try to just leave it behind this door and just thinking very truly that if somebody is good at work, at their skill and the work they do, it is because they work for it. It's not because they are a female or male. I genuinely think that we need to live in a bound, without boundaries, like the labels that people put sometimes from nationality problems and all the politics around this side. We need to have a unique equity is not something that you just can have it on paper, or the scale or the salary of females. Sometimes this is also a big discussion that brought up, that women are being less paid to compare to men. And as long as I think these campaigns are good, but we mustn't overrate what women do. We need to just think everybody is good for what they do and what they know. The other thing I wanted to say, these pictures are from Guardian news, the Telegraph newspaper, sorry. So I think they did a really great work last year. I'm thinking they probably do it tomorrow as well. So they provided like a quote of different female leaders around the world, not only leaders in any area. So I suggest you to look at the newspaper tomorrow. And another questions I have before we start the actual tech conversation tonight. Do you know what are the 3 critical success factors for women in today's society? I'm asking from the audience. You can just throw some ideas here. Education, okay. Any other ideas? Social class. Okay, that's all related. One of the main key factors are performance. Like women need to work quite well and show a lot of performance, like high quality performance, to be able to be recognizing what they do. The other area is perceptions. Often the problem with women in their career, we often don't believe in ourselves because we kind of have the kind of a biased background with childhood that a woman is somebody that just be a mom or a wife and you cannot do what they are good at it. And this self-disbelief, like kind of low self-esteem, it comes almost in every human heart, I guess. And what is important to do to change that is from us, that we need to have a better perception about what we are good and what we can do. I tell you a very interesting fact here. In job interviews, they have an statistics, like very concrete and solid statistic, that almost 70% of men, they apply for the job, then they might have 50% of the skills, but they're still so confident that they would apply for the job. Whereas for female, this rate is going to decrease almost 50%. Almost 30% of women, they apply for a job that they make good 95% on it. So they cannot even if a woman is kind of confident that I have 80% of the skills of the job, they wouldn't still apply for it. So this is shocking. So it's kind of, we need to change the perception that if we are good at it, we need to act on it and we need to know about it. The final part is networking, which is actually something that we often don't do. I think it's also different from society and cultures and differences. So these three factors happen to be the main factors for women in their success, career success. But the shocking part of this is the rate, the proportion of each factors. So if I release you the proportion that how much each of these factors is important, I'm sure the female audience in the room, they will be shocked, because we don't actually believe in this proportion. We do the other way. 10%, 30%, 60%. While we do all our focus and attention to prove ourselves, we work very hard for it, we get higher education, we study and we do good in exam and things. We don't do much networking. We often are shy to talk to our male colleagues. We often are shy to prove ourselves. We don't go to social events, even with the rate of today. Although to say is, I'm very pleased to see it's a great show up of the audience, and I know it's a very important even in Bristol, this monthly meeting. But still, we need more collaboration from women, and this is something that women often don't do. And perception also play an important role. So 30%, we need to believe in ourselves to get to have success in the career. Okay, so by saying that, I'm conscious about the time, and I know you are here to hear all great things about Azure Cloud. So I just want to finish my talk with this part of my talk about that. Believe in yourself, believe in good work that people do without the bias of gender or race or nationality, and do the good work. You know, you don't have to do all the hard work, just do the good work, and then it will show up eventually. Okay, thank you. I think we can skip that. I very briefly talk about my education and career timeline, just to give you an idea that in over years I just follow a different path. I left Iran in 2005, and then in 2008 I started my I finished my master degree, and 2010 I started PhD, and I also worked with IBM-Research in Australia, and 2016 I came to UK. But I am also a writer, and I did a creative writing degree in English, and I have some translation work in Farsi, my own language. So I want to say the point I have here is there is no only one path for you to success. Always follow your dream, believe in yourself, and try different ways. And whenever you feel that there needs to be a change, just make a change. I am a person who did 2 times migrate to 2 different countries, and I am still living, I survive. So it's not a really change, it's always a good thing, although as much as it seems hard. That was a part of that. Okay, let's start the interesting part of it. I hope I haven't bored you yet. And why the AI and advanced analytics are important, everybody talking about it, and this machine learning also becoming very important concept to different organizations. If we think of the industrial revolution timeline, we had in 17th century the steam engine come and electricity in 1870s, and the time of 70s, 90s, 1970s started of electronic and IT. On 2015 plus, we have the digital transformation era. If we say the society of human society have all these big changes like over years, we are seeing the pace of the change happens here in 2015 above. So it's been every day new technology are being introduced, different big companies every day they are bringing IT and technology into your life, kind of ingesting your life. Our movies are all science fiction based and giving you a lot of crazy ideas that how the technology can take control over you. So although the big changes happened before and they changed our lifestyle, the pace of the change is actually happening here. That's why this is the era of AI and digital technology. But what is AI actually? What is artificial intelligence? You cannot say AI is one thing. It's an umbrella term that can cover different technologies such as machine learning, deep learning, custom vision and computer vision, NLP, natural language processing. And in general, the idea of AI, in the next slide I tell you where has it come from, and you will see how the pace is small. The pace is fast because it's just kind of a 70-year-old technology, but it's getting everywhere now. So we want, and the idea of AI that a machine can think as intelligently as human with three characteristics: reasoning, understanding, and interacting. So artificial intelligence says, I want intelligent display by machine. And then inside artificial intelligence, there is a narrow topic to call machine learning, which says that algorithms start learning from data, the data that we generate every day. And one level deeper than machine learning is the concept of deep learning, where it says that let's train the machine to learn by themselves, layer by layer, with the concept of neural network, and get the idea of how, what is inside that we cannot see it as human being. So with this definition, let's have a quick AI timeline. So AI actually, if you don't know, or I might surprise you, AI actually started in England. The Alan Turing, a mathematician and English mathematician in 1950s, started with the idea, how about if we design a machine that can as intelligently as human being. So as you see, the technology and the concept is not really new. It's not really old actually, it's just 1950s. And the very great movie that has been produced based on his life, it's called the Emulation Game, if I'm not mistaken, and it shows how in Second World War II, Alan Turing helped to decode the German code, and he actually had the real effect on the winning of World War II for England. So, and this is a very, very interesting game, interesting movie. I really suggest you to watch it. So in 1960s, there were a lot of expectation from AI, and then, wow, if we have a machine that can as intelligently as human, and it can perform as good as us. And in 1970, the AI actually failed because the expectation didn't come true. And at 1980, there was a new perspective in AI. It's called machine learning, which is the idea of learning from data. So they say, okay, human brains is much complicated that you can design a machine to think as that. But we are not good in some certain tasks. We are not good in computational. We are not good in heavily engaging tasks, or we are often mistaken in understanding the data when massive data coming in. So how about if we build a machine that has powerful computing and can help us to understand the data? That's the start of machine learning, which is kind of 50-year-old actually. It's just not really old, just kind of a new era. And 1990 was the blossoms of AI and machine learning. A lot of new algorithms have been created and optimized, and over years it's still continuing until we have every day the concept of machine learning academic. If you just search on Google Scholar for any algorithm, you see that a lot of new optimization comes. However, it's again around 2000 to 2010, they started the idea of that we have cloud computing, we have machine learning and powerful algorithm, but we have big data. Big data, that every data today that you use in Google, like just for searching, is generating millisecond. We are generating data, each of us. So where this is data going to be analyzed? That's the concept of big data, and that's the way that deep learning started. That let's say we cannot deal with traditional of AI and machine learning. Let's create neural network, which they learn level by level, and let the machine to decide that. And in 2017, deep learning is still a very, very hot topic, and it's really effective in image processing and sound processing, because the dimension of the data is a lot. So for example, for an image, imagine that how many pixels this image has, and how many computational layers the machine has gone through to just get like an image recognized. Is it, for example, a shape of a 5 or 6 and so on? So that's the concept of deep learning, and every day you see a lot of new technology and achievement in deep learning. In 2017, Google brought the idea of automated machine learning, which is actually in Google Cloud. You can still go and just play with it. In any of these clouds, there's like a free version in Azure as well. I will talk about Azure. So in automated learning in Google is mainly based on vision and image recognition. So Google using its own engine just to do the helping you to learn about images. And in mid-2018 and continuing in 2019, Microsoft followed the automated machine learning, which I'm going to talk to you about. That is just an AI timeline for you. There's some statistics, quite shocking statistics. I imagine I had an expectation that some of you are startups and you have kind of business, so it might be interesting for you that why today AI is important. These are the statistics that 85% of enterprise would use AI in 2020. The AI transformation started with digital agents, intelligent apps, and business processes. So any successful business and a startup or company need to have these three pillars to get started the AI transformation. 90% of the changes will happen by 2025 by digital agents, which we all already fed up with it. When you log into your bank account, there's a chat window coming up, or you're going to shopping center, like do a Amazon shopping, the recommendation, and an engine come, like a bot come to you and say, hello, can I suggest you something? And everything that you do today, the agents that come into your life, these are kind of really overtaking our life. These are happening by bots. application, any application, every day your mobile phones, either Android or iPhone, you're still using a lot of application, new application coming to you every day and kind of taking over your control, like anything it will just do it. So it's kind of again going to be continue. And especially in enterprise, I personally work in enterprise cloud for UK, and I cover public sector, which is a difficult sector, local government. They're very resistant to the idea of cloud and AI transformation, but believe me, they have started talking about it, even with the old infrastructure that they have. So it's coming to life now, and it is the time to start this. In Microsoft, this is the keynote speech from 2016, which I should have updated with 2019, but basically this is the message that we want to bring intelligent cloud and intelligent edge to everyone, and we want to make everybody use AI. So the idea of, especially for Microsoft, without being I'm trying to be quite biased here, unbiased, sorry. That came wrong. But having said that, I work with IBM, I support Google as a scientist, let's say an applied scientist. I would say that today we don't need everybody to go to university and study 5 years at the university just to be able to work with AI. This is the idea. No, we don't need that. We don't want that. We want to make everybody enable everybody to use AI in everyday life. That's the idea of any big company, and also how government in their budget planning they are putting this as a priority to make everybody, to enable everybody to understand AI. Well, from now on, I have to be a little biased because I'm talking about Cloud Azure, but yeah, let's move to Microsoft AI. What is our transformation in that? We believe in delivering data, so we deliver data either through transfer, analyze, we capture and manage, and then we visualize and help you to make your decision based on that. So it is always starting the question, the cycle is always starting from you. We ask you about your requirement, what you want to achieve, and then we provide you the technology and we help you to get to this stage. But what is cloud? What is Microsoft Azure? Like cloud environment, it is actually a cloud, so it's kind of on a sky. In 2008, Azure started and officially getting so popularity from 2014 when there was a change in CEO. So Microsoft changed from a service software company, which is Windows and all the updates from Windows, which I'm not a really Windows person, but it moved from that and came as a cloud provider, which is getting kind of at the moment is either second or first. Sometimes it beat Google as well. So the idea of Microsoft Cloud is hybrid, productive, intelligent, and trusted. We provide 4 fields for you to get to transfer your business to the cloud and use the technology of the cloud. So you can have, it's the only consistent hybrid model in cloud competitors. You get the concept of security with Active Directory. You can have the infrastructure still on premise, and you only move what you need to cloud, the application and the processing that you need to do, and then you can still have your data secure in your infrastructure. And there is a concept of SQL Server, which is a traditional knowledge bases, and then continues to kind of a CosmoDB, and all the new graph databases are available. And also you can even have kind of a stack in the cloud, kind of a private area only for your organization. So it helps you with all these features. It is not the only services. Yep. So I'm sorry, I skipped one slide. I think for some reason my laptop is a little slow. Okay, so well, this is very, very briefly look of what is available in cloud. In Azure, we have over 600 services, and as you can see, it covers in different areas. So from security and management until advanced analytics and IoT, there is a capability, all the capability of compute, storage, and networking, the infrastructure services. But we often see that at the enterprise level, many of our customers are at this level, and we help them to come to analytics or application side. So overall, this data has been updated every time. So I think now it's over 40 Azure regions, and we also have service providers, which is covering different parts of the world, and then there is no really number of enterprises that are using Azure at the moment. There is a big popularity in the cloud now. So what actually cloud landscape AI in Microsoft has happened? We have different ways for you to deal with the AI capabilities. At the very basic level is application side, when you can call an API and use the services and embed it in your application. At the second part, you can use the application, which you can use our cognitive services or bot services, and kind of customize it in your own way and have it embedded into your application. At the third level, which is as if you are a data scientist or you are interested to do some machine learning experience or deep learning, we have the capability for you to start working with it. And today I'm going to talk about AutoML in focus, which is actually falling in that part. And at the end, you can go also to AI solution gallery that provide you with a lot of solutions in AI and libraries, and you can use. So in Microsoft, we do AI as an agent, applications, services, and infrastructure and tools. So another way to categorize that, these are the tools, services, infrastructure, and deep learning framework. I'm sure some of you are quite technical to have worked with some of this framework. So the idea is to give you the message that you can choose. We have it on our platform. You can choose what you want to use. And in particular, what is really important that today talk is going to be focused on that is AI services. So you have the AI services, which is machine learning services, and also AutoML comes in that category. What is machine learning? I've been talking a lot about it, and just let's have a very look what is it actually. Machine learning, as I talked before, is a new perspective in AI that say let's learn from data. So it's kind of getting the value from data to decisions. So at the bottom level of this chart, you get the statistical way of looking at the data, which is an example is Excel that we are using it. And as you see, the manual process is quite heavily engaged here because you still need to put the data, clean the data, run the chart, and blah, and all the things. At the one level up, you get the interactive dashboard, which is known as business intelligence. Has anyone knows what we have in Microsoft for this part? Business intelligence?
Power BI.
Power BI, thank you very much. Yes. So this is one of the, actually, it was Tableau was one of the successful tool in business intelligence, but now it's losing its place to Power BI, and Power BI is becoming very popular. It is free for you. You can all download it today in your Windows machine for free, the desktop version, or if you have a Mac, you can also use the cloud version, the application version, and it's a very, very cool tool, just to give you an idea and help you to build dashboard, interactive dashboard. So I do recommend, if you are into visualization and understanding the data, this is the right tool for you. At this third level, which is kind of most enterprise level companies and organizations, they are at this stage, prediction, which is using the historical data to build the ML model and then learn from the data to let the machine to predict what they're going to do, how it's going to happen. So many organizations are at this level, and we have services for that, such as Azure ML services or Visual Studio, and all the services that are available in cloud. At the bottom level, like a very high level, is the concept of automated decision making. Can we bring the machine to just start learning about what they can without, as you see, the manual process and the interaction of human is being very kind of reduced from here, and then we are giving the recommendation and everything to machine. One of the very, very cool example of recommendation is happen in your supermarket. Every day you go for shopping, you see that they recommend you, they put particular product together and give you a discount. For example, if you buy bread, you can buy milk with this discount. This is based on the analytics that they do every day, based on your shopping behavior and pattern. They get an idea that, for example, in Tesco, they suggest you particular product. And the same as Amazon, when you do shopping, it gives you these ideas. So these are our recommendation system, which is just looking at your behavior and historical data from your side. AutoML sits in that part. So we are letting the machine help you to build the ML, and you don't need to have all this manual process yourself, and you don't need to have a PhD to design the model. Okay, so that's why I'm hoping to be able to cover it very quickly. Machine learning steps are three main steps for machine learning. You collect and prep the data, which is a very important and time-consuming step. And then you train and evaluate your model as long as you get to the reach accuracy and you reach to the higher accuracy. And after that, you need to scale it up and operationalizing the model. What we have in Azure services, we had Azure Data Factory and Azure Databricks to help you with the preparation and collection of the data. For the trained model, you get Azure Databricks and also AML. And with operationalizing and manage, you get AML again and Databricks. So I have to skip this slide because I really want you to see the demo. And but the idea of collect your data and put it in different, you always ingest the data, you store the data, and after that you understand and transform the data. These are the main steps of the collection. And with the evaluation and training, there are different ways of training the data. It depends on your ML model, which you don't need to be worried about that in AutoML because we take care of that. But I just want to have your attention how much work needs to be done until an ML machine run. Okay, so I want to see that how AutoML made it easy for you at this stage. And with management, it's very important to run the model and scale it up. So you must have an ability to run the image in anywhere you want, such as Docker and Kubernetes and so on. So it's all possible in Azure. Very short overview of supervised learning and unsupervised learning in machine learning. Whenever your data has label, your data has labels, so you can predict the next label for the test data. That's supervised. If your data doesn't have any label, it's unsupervised. The common machine learning algorithms are classification, either you are class A or your data is class A or class B or multi-class. It's just an idea. It's a supervised learning model. Regression is also supervised learning, where you trying to identify a fit pattern to your data. One of the very feasible example of regression model are predictions of the weather. When you check your weather app every day, every morning, it tells you, for example, today is 2 degrees hotter than yesterday. That's the prediction model, and it's calculating, looking at all historical data that they have on the server, and gives you a prediction level on that. The other famous algorithm is anomaly detection, which is actually identifying an very different pattern on your data, and you just suddenly see all these cats, one of them is dog. This is definitely something going wrong. Very cool example of that is fraud detection. And your credit card, you may get a call from your bank that say we stopped the transaction. This is the fraud detection that they show. For example, this is not the usual patterns of yours to use the card. So bank uses anomaly detection a lot for just to recognize that. The final and important part of supervised learning, unsupervised learning in clustering, which is that I have no idea about my data. I don't know what is the level of my data. I just want to throw out a clustering algorithm, and it tells me how these are related. These data are related, and giving you a very cool clustering information on that. This being very useful on that. So having said that, I just wanted to get an idea of machine learning and algorithm. So what is automated machine learning? Automated machine learning is help you to pick up an algorithm without really knowing about, all the concept and theory, mathematical theory that from 1980s is building up on this really, really important science area. It's just letting you to pick up an algorithm, tune the hyperparameters of your model, which I will show you in demo, and then help you to deploy it. So how cool is that? Just imagine all this previous slide that I talk, and I actually talk very fast on that, but all these steps is helping you to just build that model, automate it for you, and you just need to run it. Okay, so that's the idea of AutoML. So remember the machine learning process that I told you before: prepare the data, build and train and deploy. That is how AutoML does everything for you. So AutoML capabilities, you get ML scenarios. At the moment in Microsoft AutoML service in cloud, we have classification and regression for forecasting, which is a type of regression. It is coming to GA in March, end of March. Integration, you get integrated with Azure Machine Learning, Azure Notebooks, which is a Python notebook for you to be able to run the command. I will show you the demo quickly. And the data types, at the moment we only support numeric and text. If you want a very cool image processing on AutoML, use Google Cloud. For languages, we follow Python. There has been a controversial conversation about is a Python good or R in data science domain, and I think the agreement was let's go Python. And the reason that Python has a very cool open source library called scikit-learn, which AutoML SDK in Microsoft is based on that, so you can use that. And with training computing, you can either run the SDK, the model on your local machine, or you can use a virtual machine from the cloud, or also Azure Databricks is coming to live in March. With transparency, you get a transparency of run history, and you can decide which model to choose. I will show you very quickly on that. And then you can also scale and pass your data. So by saying that, I'm almost at the end of my slide. So here in cloud, Azure Cloud, we offer you an end-to-end process for machine learning. So you prep the data, you use the experiment environment to build your model, and you train the model, and then after that you register your model. And once the model is being registered, an image is built that help you to run the image in any environment that you want. You don't want to stick to cloud. You can run the image on your premise and just go with it, done with it, and work with that. And then it's kind of a orchestration on that. So in just a brief review, Azure Machine Learning Services, with the help of Python SDK and the Azure Cloud Services, help you to do all this in one place. And this is again the workload steps. It's just a repetition of what I already said. And machine learning on Azure, again, you can use either as application level or as coding level or deployment, and you can also use different compute targets, and you can use it anywhere. This is a hybrid model. It's all your choice. So having said that, let me just quickly jump into I think I'm a little over time, right? I very briefly, I just think you probably want to see a very cool demo of Azure. This is I'm talking to my screen. Okay. This is the cloud environment of Azure. This is the cloud environment of Azure, and you need to, once you go, and I really suggest every of you can today go home and have a free edit on Azure, £150, and just start playing with it. And this is completely like a very, 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 very easy environment to start with. So you choose the particular source that you want to create and build on. There are very good documentation on how to use each of these services. They are all available public in Microsoft Docs. Just go and check that, and you can use any of the services that you fancy to just test it. With AutoML, this is the Azure Machine Learning Services that I have already created. And as you see, this is the UI version, which hasn't come to live yet. I have a private preview access to it, but it will come by end of March. So you will be able to see it quite soon. So this is what I wanted to explain to you. I ran this. This is the model in SDK, or it is not maybe. Oh, I need to sign in. Okay. Yep. So I just find you. Yeah, okay. While it's being restarting my notebook, I want to show you that there's a very cool pipeline, Python pipeline on that code, on that notebook that I'm trying to bring it live. So, yeah. So here, let's say that this is a classification model that has been already built. This is AutoML. So once I run this Python script, which is kind of magically, not magically, like I set up all the parameters on my Azure Cloud, it creates this model for me. which is this model has been run I have a pipeline. I loaded the data set into that SDK, I ran it, and then it ran over 25 iterations. And because it has a pipeline of all the algorithms that I briefly just walk you through, the 4 main common algorithms, in each of this category you may get 50 algorithms, so you don't know what is happening back. The machine, once you run the data and you prep the data and run the SDK, the machine starts using the right algorithm for you. And in each iteration, this is the part I'd like you to have your attention, the accuracy gets improved. So this is like kind of my run history. So it shows that each time the machine is choosing the right algorithm and it is improving the accuracy. And it's not doing that by random. It is actually computationally expensive. And it's using a very complex computation by feature engineering and selecting the best run and so on. It is doing that for you. And the only thing that you need after running this over a cluster, a computing target, at the end, you get to this, for example, here I reached to 91% accuracy of my model. Okay, and then I am happy with this model. I can download this model, and I say this is my model for the data. And I didn't do any preparation or cleaning of the data. I just let the machine do everything for me. And it's not doing it by magic. It's only running this code, the SDK code, which is, yep, perfectly fine. So here you see that how the SDK is being run. So, well, I think it's not helping it. I'm not using my, yep. So you say that, like, for example, there are different parameters that you need to set, and there's a very good documentation for that. So after that, I want just to have your, like, see, this is the iteration, pipeline, and duration. This is the same as you see in the UI version. So it's actually showing you that how it chooses these different algorithms, right? This is the 2 different experiments, by the way. If the name of the algorithm are not the same, don't be surprised. I'm just trying to show you the difference on the SDK and the UI. And once I download my model, I have a very cool way to look at it here. So this is kind of, you get the pipeline. This is like the end-to-end process. I run the experiment. I am happy with my model. I load the model here once I agree. And then I have a pipelines here that I can run. I choose my compute target. So you can start with 1 cluster. You can go with 2 clusters. You can choose Databricks, whatever you want to like be in your model. And then at the end, you get an image that you can scale up that image. So this is the whole like very, very short brief of AutoML, and showing you that how this complex automation is coming to life, quite easy and interesting way for you to work with. Thank you very much. I'm sorry about the time, and hope you enjoyed it.